Now, if we look at how well did these things do economically, here's a summary of different systems at the in the Florida area. The one on the left-hand side is the geothermal heat pump completed in August of 2000, and that's the green one. The average savings over other school buildings in the same school districts is about 39%. If you go back to those first slides where we talked about source to load or load to source, you can see we were talking about numbers about like that. And so, here it is demonstrated. The yellow one is a system that has a gas boiler and a chiller system. It was updated with new equipment in 1996, but it still has the higher operating cost. And then finally, the red schools right there, or schools depicted in red, are multiple systems. They could be any kind of system: an electric boiler with heat pumps, gas boiler with heat pumps, variable air volume, just higher operating costs. I mean, we just don't like to keep on bragging, but we're going to keep on until everybody believes us. More school histories. This was in Kentucky. A study done with different technologies. Geothermal heat pump on the left, heat pump with electric boiler, then heat pump with a gas boiler, 2-pipe, 4-pipe, and you want to take a look at these things, because as utility or as fuel costs change, you'll want to take a look and make sure that this is going to suit your purposes. Lower first cost, lower operating cost, the best thing for the building owner. Throughout this CGD, Certified GeoExchange design program, we're going to be talking about system components, buried plastic pipe, what kind of material you use, high-density polyethylene specifications, so that you get good high-density polyethylene pipe. We want to make sure that you use joining procedures which are going to be reliable and are going to be stand the test of time. Heat pumps, there are 3 different kinds of levels of heat pumps depending upon application. You have cooling tower and boiler, you've got groundwater, and then you've got geothermal, and each one of these has a temperature range which require different kinds of heat pumps. But what really dictates which one of those heat pumps you use are the range of fluid temperatures that are going to come to it. You wouldn't want to use a geothermal heat pump project in a commercial building where the cooling tower and boiler was going to be obviously control the temperature much more closely than the temperature ranges that you get with geothermal. Antifreeze fluids, if needed. We want something that's safe, non-toxic, non-corrosive, that will last a long time. And then circulators. I showed in the previous slide a primary and secondary pumping system. That's not the only one out there. We have a large number of projects where, like on that hybrid system there, where each heat pump had its own circulator. That really minimizes the pumping costs. If you can design a heat exchanger system as well as the interior piping system that you can flush the air out of, there's no reason for you not trying something like that. But there are some design guidelines that are available for that. System design, we're going to be talking about open loop, pump and dump, pump it out of one well, dump it into another well, or dump it into a pond or a stream. Standing column well, ponds and lakes, where we take the water, maybe use it directly or indirectly. Closed loop, vertical, horizontal, hybrid. And then soil and rock thermal testing. We need to know what the thermal properties of the soil are. We don't need to be guessing about that. And we'll talk about that in later sessions. And then grounding of the borehole, because you want good contact between the plastic pipe and the formation. This is a slide that we'll get into in greater detail later on in the course. Dr. Smith will be talking about that. Each one of those curves has a different different treatment between the pipe and the borehole and the formation. The lowest curve on the page is the best, and you can get that by using thermally enhanced grout and spacer clips on the pipe. And the top one up there is you just bore the hole into the ground and backfill it with a bentonite grout. and a standard pipe insulation. So the lower the curve, the better, because that's the lower temperature rise that you would get. And so that's very important, and we'll talk about that in great detail, about the different performance that you can get. The thermal testing, we don't know, and there are various layers in the ground, and so it's important that we know what the thermal performance of the whole borehole is. And here is what we call an in situ, depends on what part of the country you're from. We take a constant hot water source and a circulator pump, and we circulate that in a ground heat exchanger that's in place and has been grouted. Then we measure the thermal response over time. And that's enough information there to give us what the thermal conductivity is. And we don't care how it changes throughout the borehole. All we want to know is what the value is. Our existing resources for design, you've got a number of books here. Some developed at Oklahoma State University. Steve Cavanaugh developed one with the ASHRAE, which is a good one. It's included. Manufacturers always have training courses for you, and then there are a number of conferences throughout the country and also here at IGSHPA. If you go to our website, you can find out about those. There are a lot of people involved in this: the electric utility people, commercial building owners, technology specialists that work with engineering firms. Last but not least, you have IGSHPA, and you have the Geothermal Heat Pump Consortium. We each have different missions, but we each support each other in their technology. We want you to become involved with this technology, and hopefully you have been, because you signed up for this course. I thank you for listening to me today, and you'll see me again with later lessons.